It's a positive odd. Thank you. So n is equal to 3. N is equal to 2. It's a positive odd, which means the graph starts how? Starts how? Down, and it finishes how? Up. Next thing, I need to get the possible rational zeros r. So what is r equal to here? How do you find r again? What do you look at? So factor of the last numbers are what? Plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus what? 6. And we're going to divide all those by plus or minus 1. So it's just the numbers at the top is what it's going to be, right? Anybody find any x-intercepts yet? Say it again. 3. So one of the x-intercepts is 3. How many do we need to actually start to solve this problem? You need 3, but we only need 1 to start the process because one will get us down to a quadratic, right? So taking 3, lifting out the coefficients, you have 1, negative 2, negative 5, and 6. Bring the 1 down. 3 times 1 is 3. That's negative 1. 3 times negative 1 is negative 3. This is a negative 8. That's not right. Oh, positive 1. Thank you. I'm sorry. That should be a positive 1. So this is 2. Negative 2. 3 times negative 2 is negative 6. So that's a 0. And you're left with this quadratic here. You're left with the quadratic x squared plus x minus 2 is equal to 0, right? How do you factor x squared plus x minus 2? What are the factors of negative 2 that add to 1? Factors of negative 2 that add to 1. Thank you. 2 and negative 1. So x plus 2, x minus 1 is equal to 0, which means x is equal to negative 2, and 1 is the last two solutions, right? So there are your 3 solutions. Put them on your number line. So we have on this one. Oh, I'm sorry. No, I'm sorry. Negative 2, 1, and what does that mean? That means I'm not gonna give it to you. Oh, it might be. Is it 1? Let me see it. Graph starts down, finishes up. Are there any repeating roots? No. Oh yeah, that's right. Just write it out. You're right. Just write that out. Starts up, finishes down, and goes like this. There's your graph. Hey, we okay with this part? With sketching these? We've been doing this for a while now, so we should be okay with it. Let's talk about this, and we're going to talk about what's called a polynomial inequality today. What is an inequality? Yeah, it means it's not equal to. So how do we show inequalities though? What symbols are those? Yeah, those are going to be the less than, greater than, or less than or equal to greater than or equal to, right? And for these are special now because when you show them, their solutions are going to be, the solutions for these are either going to be 2 ways you can write the solutions for these type of problems. The solutions are either going to be through what we call a number line and a number line. And when you show it in a number line, basically what we're going to do for these inequalities is do a sketch. So these are going to be your sketch. And then you can also write it in interval notation, which we should know interval notation. And then more importantly, interval notation, it requires us to use the brackets and the parentheses, all right? So on a number line, how do you show that? How do you show these symbols on a number line? What do you show? Open circles. And how do you show these on a number line? Closed circles. Everybody got that? Number lines, open circle, closed circle, that means to, this one means to exclude. This one means to include. And then you're also going to show exclusion with the parentheses, and this with the brackets. And here's how this is going to work now. what you're going to do is sketch these polynomials again. So you're always going to sketch these like we've been doing. So you have something like this. You have this function that does something like this again. And what you're interested now is this. For this, your intervals are going to be set up to where either f of x is going to be greater than 0, or it's going to be less than 0, or it's going to equal 0. So it can be one of three things. You have this function f of x, right? This right here, this number line represents your y-axis. That's your y-axis for f of x. So at the y-axis, f of x will equal what? What's the value of y at the y-axis? 0, right? And then we look at it like this. Any part of the function that is above the y-axis. Any part of the function that is above the y-axis is going to be, with respect to 0, is they going to be greater than or less than 0? Greater than. So when we talk about the function f of x is greater than 0, this just means that you're above the y-axis. And any part of the function that is below 0 means that it's what? Less than 0. And this means that you're below the y-axis. So here's how this works. Here's an example. Let's take the function, take the function x cubed minus 2x squared minus 5x plus 6. And let's let this function be less than or equal to 0. Well, the good news is that we just drew this function, right? So we know our x-intercepts are going to be -2, 1, and 3. So -2, 1, and 3. The first part is to actually set up the number line, sketch the number line out, all right? Here's how you're going to sketch it. Once you have the sketch of the polynomial drawn, all right, the first thing you're going to do is decide if you include or exclude the intercepts, the x-intercepts. Based on the symbol right here, do I include or exclude those intercepts? Include them. I'm going to include these. How do you show inclusion on a number line? Close circle. So at all the x-intercepts, I'm closing the circles. Everybody understand that? Yes? Now, I want you to decide less than or equal to means it has to be either equal to 0 or what? Is it above or below? Below 0. Where is this graph going to be below the y-axis at then? 1. Well, it looks like it's in between. You can see it definitely below from 1 to 3, right? And it's also when it's less than what? -2 out this way. So you're going to shade those intervals on your number line. This? Oh. So what does this arrow mean right here? So that's -infinity up to -2. Do we include or exclude -2? Include it. Union. Then from what? 1. Include the 1, 2, 3. Bless you. And here's the answer. Y'all got that?
Yeah.
Let's do another example. You what? Yes, you already got to solve. You have to draw this sketch first. So here's another example. Let's do 3x to the 4th plus x squared minus 12 is less than 11x cubed minus 19x. before you start this problem, what do you think you have to do first? Put it in standard form, and that means when you put this in standard form, you need to have everything moved over to have this equal to 0, or set it less than the 0. Do you understand that? So this has to be set to 0 on this side. You always set these to 0 before you start them. So setting to 0, you get 3x to the 4th minus 11x cubed plus x squared minus plus 19x minus 12 is less than 0. Now, I want you to sketch this. Go ahead and sketch this, please. So go ahead and find those solutions. I'll give you time. How many solutions do I need for this equation here? 4. So n is equal to 4 and m is equal to 3. What kind of graph is this? So positive, even. So how does that start? Up and it finishes up. Good. Listing out all the possibles you can get for this. R is equal to factors of what number? 12. So that's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12, right? We're going to divide those by all the factors of the first number, which are plus or minus 1 and plus or minus 3. So when you start dividing numbers out, you're going to get plus or minus, well, all the ones divided by 1 are just going to be the numbers on top. So you get 1, 2, 3, 4, 6, and 12. Then you divide them all by 3. So you're going to get 1 divided by 3 is 1/3. 2 divided by 3 is 2/3. 3 divided by 3 is 1. We already have it. 4 divided by 3 is 4/3. 6 divided by 3 is 2. We already have it. And 12 divided by 3 is 4. We already have that. So here are your possible solutions. How many do I need to get it down to a quadratic? I'm at 4. How many do I need to get it down to a quadratic? 2. So what is x equal? Anybody find 2 of them yet? 1 and 3 will work. So let's try those. So put 1 first on the shelf. We get 3, negative 11, 1, 19, negative 12. 1 times 3 is 3, negative 8. 1 times negative 8, negative 8. 1 minus negative 8 is a negative 7. 1 times negative 7, negative 12. So that's a positive, negative 7. This is equal to 12. 1 times 12 is 12. That's a 0. 3. 3 times 3 is 9. That's 1. 3 times 1 is 3. That's negative 4. 3 times negative 4 is negative 12. That's also a 0. So the quadratic you're dealing with is 3x squared plus x minus 4 is equal to 0. How do you factor 3x squared plus x minus 4 equals 0? What do? Multiply the first times the last. You're going to get what? Negative 12. Factor the negative 12 that add to positive 1. Help me out. Thank you. 4 and 3. So we need 4 and a negative 3, right? So it's 3x squared. I'll do it like this. Minus 3x plus 4x minus 4 is equal to 0. We have 4 terms we're going to group. What do the left-hand terms have in common? 3x. And you're left with a x minus 1. What do the right-hand terms have in common? And you're left with a x minus 1 again. So you get the terms 3x plus 4. X minus 1 is equal to 0. What are your solutions going to be here? Negative 4 over 3 is one of them. The other one is what? Positive 1 again, right? So what does it tell me about the number 1? It's repeating because it showed up twice. I got that? So we make our number line. On the number line we have the numbers negative 4/3 is first. 1 and then 3. How does the graph start? Up. How does the graph finish? Up. Is anything repeating? 1 is repeating, right? So what does it tell me that happens at 1? When I get to 1, I'm going to bounce. Graph looks like that, right? Now, when I look at this, intercepts. Tell me, do I include the intercepts or exclude the intercepts? Well, going back to the original problem, it tells me I'm going to exclude intercepts here. So I'll have open circles with intercepts, right? And I'm interested in when the graph is what? Less than. Everybody see that? So when is it going to be less than? Well, look at your intervals. The graph sections itself off in the intervals. You guys see that? So it looks like it's less than from negative 4/3 to 1. And it's also less than from 1 to 3. Everybody got that? Do we include negative 4/3? No, so it's negative 4/3 to 1. Do we include 1? No. And because we're not including the 1, what do we need to put? What do we need to put here to connect it? Union. And then it goes from 1 again. Do we include the 3? No. Here's the solutions. You understand this process? How is this different from what we've been doing? Are you still going to sketch something?
So much work to get that.
I know, right? I totally agree with that, man.